Hello, this is Scholastic Sam. Welcome back to my Math and Science YouTube channel. Today we're going to be discussing a common chemistry topic of periodic trends. Sorry about that. Now, periodic trends, we know that the periodic table is oriented a certain way, where with groups and periods where the increased number is with protons, which increases neutrons and electrons, causes mass to increase, all that stuff. Now, this means that certain qualities will increase and decrease going in certain directions on the periodic table. Now, these are known as periodic trends, changes when you move in certain ways that are consistent on the periodic table. Now, the periodic table is organized in a certain way. That's what leads to periodic trends. Most of them change when going, that's up and to the right, sorry, that's just left, but up and to the right or down and to the left. Now, the four main trends are atomic radius, ionization energy, electron affinity, and electronegativity. Now, this is the periodic table. As we see that these will either be decreasing and increasing, going up and to the right, or increasing or decreasing, going down and to the left. So we'll be referring back to the periodic table a lot in this lesson. Now, the first one is the atomic radius. This is the distance between the nucleus and the electron cloud. This is partially the cause of the other periodic trends. As we saw, this is the only one out of the four that decreases going up and to the right. And it increases the closer it is to the bottom left corner. Now, you're probably not going to have to calculate this, but if you have to calculate the atomic radius, if you take two atoms of the same element, and you measure the distance between the two nuclei, you just divide that by 2, and you get the atomic radius. The next one is electron affinity. This increases going up and to the right, or increases the closer you get to the upper right corner. Electron affinity is the amount of energy released when an electron is accepted by an atom. But it's also a measure of the attraction between the incoming electron and the nucleus, as we saw. The higher the affinity, the easier it is to accept new electrons, meaning that as it goes up and to the right, it's easier to accept new electrons, meaning that down and to the left is more reactive. So, yeah. Next one, electronegativity. This increases going up and to the right. So the closer it is to the upper right corner, the higher the electronegativity will be. This is the ability of an atom to attract electrons when it's in a compound. So if it has a higher electronegativity, it's going to be attracted more to other elements, which will increase its bond rate. Next one is ionization energy. Now, this is the amount of energy required to remove an electron from an atom, making it an ion. The higher the energy, the harder it is to remove an electron, meaning that ones with higher ionization energies are probably going to be less reactive. Just remember, and noble gases don't have most of these because noble gases aren't reactive at all. So, if you look at what a reaction actually is, when you transfer electrons, noble gases are already stable, and they won't involve electron transfers and thus will not be reactive at all. These increase going up and to the right or increase with proximity to the upper right corner. Now this is the overview. As we see, the force of attraction, electronegativity, ionization energy, and electron affinity increase going up and to the right. We didn't talk about force of attraction, but that's something you might learn just so you know it increases going up and to the right. But atomic radius decreases going up and to the right. Now, francium is the most reactive. So, a common lab is you might put all of the ones in this one, the alkali metal, all of those into over a fire and see how reactive it is or see what color it is. And there are different ones because going down lithium to francium is more reactive. And so it gets more reactive going down and to the left, but less reactive going up and to the right. Now, take maybe a minute, or we'll just look at this because these are going to be commonly what you're asked. So let's say someone asks you, tell me these 5 things about aluminum and nitrogen. Well, we see aluminum right there, and nitrogen is right there. Can you see that? Yeah, right there. So nitrogen is farther up and more to the right. So we know that nitrogen has a greater force of attraction, greater electronegativity, greater ionization energy, and greater electron affinity than aluminum, but it has a lower atomic radius than aluminum. And aluminum has a lower force of attraction, lower electronegativity, lower ionization energy, and lower electron affinity than nitrogen, but it has a greater atomic radius. Now, I hope you guys enjoyed this video on periodic trends. If you have any questions, comments, or concerns, please leave them in the comment section to get your answers from me or your peers, because I look at all comments. Yes, all comments. And please subscribe and leave a like if you like the video, because it helps grow the channel and help this knowledge reach more people. Also, please ring that bell, turn on post notifications so you can be updated on my new videos all throughout high school. So that way you can help ace high school with ease. So you can get all these videos, simple, comprehensive, explaining clearly what each topic is. Because teachers, they've been teaching it for a while. They don't really know it from a learner standpoint. But most of this stuff I reviewed heavily, but have learned in the past year, so I still know the learning process. Now, a shout out to Dr. B, my chemistry teacher, for teaching me all this information. Thank you guys. Bye. And always remember, knowledge is power. And join me for my next video on reactivity.